Hello and welcome back. Let's talk about partial derivatives. So in Calc 1, we originally talked about the definition of a derivative, applications of derivatives, lots of things with derivatives. In this, we'll just talk about the partial derivative because there's a lot of similarities and the applications of them are actually just used in the following videos. So let's just hop right into it. So a partial derivative, like a normal derivative, derives with respect to some variable. The only thing about partial derivatives is that they are used when we want to differentiate functions of multivariables. Multivariable calculus, this is what we're talking about here. And so how do we do that? Well, there'd be two options. Either we could treat all the other variables as constants, or we could treat them as their own functions. Now, treating them as their own functions would make things very complicated. So for that reason, we just treat them as constants. So let's get into some notation. Our notation is, instead of derivative with respect to x, let's say, now we're going to have these curly d's and still the x. And this just means partial derivative instead of ordinary derivative. And we could have the same thing. We could have partial derivative with respect to y, or partial derivative with respect to z, partial derivative with respect to banana, whatever. Whatever our variable is that we want to differentiate. And so what exactly is this doing? Well, what it's doing is it's finding the slope in the direction of that variable. So let's say that we had a 3D function, and these are kind of hard to sketch, but I'll do my best to try to illustrate this. Obviously, we have three ways that we could go with this. We have the x, we have the y, and we have the z. But it would be very hard to find the derivative, or the ordinary derivative doesn't technically exist here. What we can do is break it down into a plane, basically. We could take the x-plane, say, here, and say, how is this changing? And we could find a derivative function along the x-plane, like, say, that. We could take it back out here, and our derivative like this would be the partial derivative with respect to x. Of course, evaluated at this point here. Let's call that a. So that's what they are. Let's just take a look at some examples. Our first example is the partial derivative with respect to x of xy. Well, we can treat y as a constant, so let's take y out front. We have y partial derivatives with respect to x of x. This could just be represented as a normal derivative now, but let's not bother doing that. Well, we know this is just going to be 1 times y, which is y. Let's take a look at another example. The partial derivative with respect to y of x over y. Well, we can treat x as a constant, so this is just going to be x times the derivative of 1 over y with respect to y. That's ln absolute value y. So you can see these become very complicated. Of course, we can also have something like this. I'm sorry, did I say very complicated? I said not very. I meant not very. I may have said not very. I'm not sure. Sometimes I slip on my word there. We have the double partial derivative with respect to z, and this is represented the exact same way as the normal derivative. of zxy. So our first derivative is going to give us just xy. And then if we differentiate this, these are treated as a constant, so these are going to be 0. And that is going to be 0. So that's what partial derivatives are, how to evaluate them. Let's talk about one simple application, or I guess just something that we should know for the rest of this series. And that is the del operator. The del operator is a vector represented by the partial derivative with respect to x, the partial derivative with respect to y, and the partial derivative with respect to z. Just like that. And these have many of applications, such as divergence and curl. Divergence would be del dot some vector field. Of course, we could add that on top. A lot of the time we don't use it. Curl, del cross f, and I don't quite have a linear algebra series just yet. I do plan on creating that very soon, but I just thought I would finish with all the calculuses and then get into that. But very soon you'll be able to figure out what a dot and cross product are on my channel as well. But thanks for watching this video. In the next video, we will talk about integrals in multivariables. And yeah, I hope this helped. Thanks for watching.